Hi everyone. So in today's lab we're looking at gas chromatography, or GC for short. So gas chromatography involves the separation of volatile compounds. And volatile compounds are compounds that are easily vaporized. Okay? So in GC, our stationary phase is contained in the column. I will point the column out to you now in a few minutes. And our mobile phase is an inert gas, hence the name gas chromatography. In this case, our gas is helium. So there's a cylinder of helium connected to the column, and that's what we use for our mobile phase. So the separation of our molecules occurs based on their interaction between the mobile and the stationary phases. The GC unit that we have here in the lab is the Shimadzu GC 2014. So I'll just point out some of the components that we can see here on the machine. So the column is actually contained inside the machine in a chamber. So if I just open it up, you can see inside. So here's the column right here on this coil. If we look more closely at this column, this is a capillary column. So it's very long. They can generally range anywhere from 10 to 100 meters. This one is 15 meters in length. So it's a very long, very thin column. The inner diameter of this one is 0.25 millimeters. So very small internal diameter, but a very long length, and that allows for maximum separation of our components. This particular column is a DB5, and this is a general purpose type of column that works well for many of the separations that we do here in the lab. It's a non-polar column. It's capable of withstanding very high temperatures. So it's a commonly used column in a lot of the techniques that we do here in this chemistry course. The chamber that the column is in is actually an oven. So when this door is closed, we can maintain a constant temperature inside that space. So we can keep our column at a constant temperature for the duration of our analysis. Up here on the top of the machine, you can see the injector. Okay, you see there's a little hole there. That's where we inject the sample with a syringe. And that is generally held at a higher temperature than the oven, usually about 50 degrees Celsius higher than the oven. And that's so we can get adequate volatilization of the sample before it enters the column. So it enters at a very high temperature, all the molecules are vaporized, and then it enters the column. So our samples and our standards will be injected via the injector. They'll be volatilized here at a very high temperature, and then they will travel through the mobile phase into the column. And then after they travel through the column, they will be detected by the detector. So as the samples come off of the column, they're detected by the detector. In this case, we have an FID, a flame ionization detector, that detects the molecules as they're separated on the column. So separation occurs based on the separation of molecules between the mobile phase and the stationary phase. So molecules that are less volatile will be interacting more with the stationary phase in the column and will move more slowly to the detector, whereas compounds that are more volatile will interact more with the mobile phase and will travel faster through the column and reach the detector earlier. Okay, we're going to start by opening the software in the computer. So it's called GC Solution, and you can see here that it can connect up to 4 different instruments. We only have one, so we're going to connect to instrument number 1. And then it opens a window that will give us all the parameters for the method that we're using. So everything is controlled by the software. So I've opened a method here for alcohol that was previously established. So this one was saved in the computer. So we can create a method and then save it so that every time we do the same analysis, we don't have to recreate the method. So I just want to go through and point out some of the parameters here of this method. So let's start at that little table that you can see there in the center of the screen. That's where we set our temperature program. So we're using a gradient temperature program, meaning that the temperature gradually increases over time. So if we look at the different rows there in that table, the first row is 33 degrees Celsius. So the column oven temperature will start at 33. And then if you looked at the next row, it'll increase at a rate of 15 degrees per minute. So the temperature will go up by 15 degrees per minute until it gets to 110 degrees Celsius. Okay, and at the bottom of that table you can see total program time. So our total program time is 5.13 minutes. So that's automatically calculated based on the temperature program that we enter. So the graph up above that as well shows our temperature program, and you can see that's a nice straight line going from 33 degrees right up to 110 degrees. So that's a temperature program that works well for separating out alcohols. The other things that you can see there on the screen underneath that table, you'll see information about our column. On the left hand side there, you'll see information about the detector. So it says FID, so that's our flame ionization detector. You'll notice underneath that the stop time is the same as our total program time. So we want the detector to stop running when our program is done. Okay, so that's automatically set at the same time. Underneath that is the temperature of our injector. So our injector is at 160 degrees. So you might remember I mentioned that the injector temperature should usually be about 50 degrees Celsius higher than the highest oven temperature. So our highest oven temperature is 110, so the injector is at 160. Okay. Underneath that, there's a lot of other parameters about the flow rate. Okay, the type of carrier gas is helium. We're using a split injection mode. And then some other parameters there as well related to the linear velocity, total flow, column flow, split ratio. We're not going to change any of those. We're going to leave those at the defaults. Over on the right hand side of the screen, that shows us the parameters or the status of where the instrument is right now. So you'll notice that in yellow up there next to GC status it says not ready. That's because the temperatures are not all up to where they should be at. Okay, so as soon as everything gets up there, which it almost is there now, that'll change to ready and we'll be ready to start injecting our sample. Okay, so while we're waiting for it to come up to temperature, we can start by logging in our first sample, and we're going to start with the standards. We're going to start with the lowest, 1 ppm, so we'll enter that in. We don't need to enter in any other information here. We can if we have extra data that we want to put in there, but for now we're just going to put in the name as the concentration of the first standard. So that's logged in. Now we just have to wait for the status to be ready before we can actually inject the sample. Okay, so our status now says ready. You can see that all of the temperatures are at the starting temperature where we want them to be. So we've already logged in our sample. So now we just need to hit start over here on the left hand side. Okay, so it's running. You can see the status now says acquire. So the detector is acquiring information and transmitting it to the software. You can see our little graph is running here on the bottom, and we already have 1 peak and 2 peaks. So we do expect to see 2 peaks because we have one for the ethanol, which is our standard that we used, but we also add an internal standard, which is propanol. So one of those peaks is ethanol and one is propanol, the internal standard. So right now we aren't really sure which one is which, but we will be able to tell which peak is ethanol and which peak is propanol when we run the rest of the standards. Because if you think about the standard concentration, the concentration of the ethanol is going to gradually increase because we went from 1 ppm, 2 ppm, 3 ppm, and so on. So that peak area should increase, but the propanol should actually stay the same. The peak size should stay pretty close to the same because we added the same amount to each of our standards. So the amount of the internal standard should not change, but the amount of the ethanol should. So we should be able to see a distinct difference in the peaks as we move through the rest of the standards. So that's our 1 ppm. We'll move on to the next standard. So the next standard I want to show you is the 4 ppm. So we're going to change our sample login to 4 ppm for our next standard. That's logged in. We're going to hit start on our machine, and then it should start to acquire the data. So start, there we go, and we have a status of acquire, and our system is running. So you can see our graph starting to move across the bottom. So very soon here now we should see our 2 peaks, one for ethanol and one for propanol, our internal standard. There we go. So we can see that this one is a much bigger peak, so I'll just zoom out a little bit so we can get it all on the screen. So because of the huge difference in size of that peak, we went from 1 ppm to 4 ppm. That first peak is going to be our ethanol peak. So the ethanol is the one that the concentration increased in. So if we saw such a big difference in the concentration there, that's because of the increased concentration of the ethanol. You can see that the propanol peak didn't change very much. It's still smaller than the ethanol. So our first peak is our ethanol. The second peak is the propanol, the internal standard. Okay, so we got two nice clearly defined peaks there for ethanol and for propanol. So I will now run the rest of the standards, and as in the other labs, your instructor will provide that data to you for your lab report. So now that our standards are done, we're going to run one sample. So let's change our sample login. I'm just going to call that one sample for now. Hit OK. And our system is ready. So we're ready to hit start. There we go. So I've injected the sample, hit start, and now our system is running. So every time I've been hitting start here, what you can't see, I guess, in the background is I'm actually injecting the sample into the injector with a syringe. So I'm injecting 0.1 microliter every time. So this is our sample. Now usually in our samples we expect to see more than just the two peaks because there may be other compounds there as well. So we're getting one peak. I'll just increase that a little bit so you can see the division. So we got one peak, another little one there just to the right of the first peak, and then a third peak as well. So if we compare the retention times to our standards, the first peak is our ethanol and the second peak is our propanol. So we do have one other compound there that we haven't identified. So now that we have our sample done, you guys can calculate the concentration of ethanol in that sample by using your information about the peaks for ethanol and propanol, and all of that data will be provided for you to use for your report. So I hope you learned a little bit about gas chromatography. Thanks for watching, and we'll see you in the next lab.